What's up, everybody? So today I'm going to be doing a math homework problem. I got this idea from Parrot. Make sure to go check out his second channel. This is an example of a college level calculus 2 class problem that we're going to be taking a look at today. So we have this function, which is the integral of x cubed ln of 1 plus x dx. And so the question is to write the power series of this function. Now this is pretty confusing, but a series is a sum of the sequence of numbers. So a sequence of numbers is 1, 2, 3, so on and so forth. But we're just adding all of those numbers up. For different functions, including this function here, it can either add up to infinity, or it can add up to a certain constant, or it can add to 0. It depends on, you know, a bunch of certain factors. But today I'm just going to be kind of explaining how this problem in particular works. The Maclaurin series. This theorem states that a over 1 minus r is equivalent to the summation from n0 to infinity of a r to the n. This is how we're going to be getting this function up at the top into a series form. This is a series with the summation. The Maclaurin series states that we need it into this form, but for some reason, that's a really bad color. We need it in this form, but as you can see up here, this entire function is nowhere even close to a over 1 minus r, so we somehow have to convert it into that using some fancy algebra. So let's go ahead and begin this problem. Okay, so this is the function that we have to work with here. So this is the same thing as the integral of x cubed times ln 1 plus x. And so this is the same thing as saying this. We want to convert this into something that looks like this over here. So how are we going to do that? This is the same thing as saying taking the integral of 1 over 1 plus x. So you can actually see that this is really close to actually what we want, the a over 1 minus r. But unfortunately, we don't have a minus 1 here. We actually have a 1 plus x. So we're going to go ahead and rewrite this again. It's going to be the integral of 1 over 1 minus a negative x. And there we go. We now have that in the proper form. So now we can start to convert into a power series. So the example is going to be the summation of infinity n equals 0, which would be negative x to the n. Then we can go ahead and distribute this n out to a negative 1 in front. So it's going to be negative 1 n x to the n. Now we can go ahead and continue further by applying this integral inside of the series. And when we apply the integral inside of the series, we're just going to be taking the integral of the x is going to be powered up rule. It's going to be the power rule. So you're actually going to be going to from n to n plus 1, and you're actually going to be dividing it by n plus 1 as well. And now let's go ahead and continue by multiplying this x cubed into the series. And how we're going to do that is by using exponential rules. If you haven't learned anything about algebra, then this is going to be pretty cool, in my opinion at least. So if you have x cubed multiplying by x to the n, exponential rules state that when you multiply exponents with like bases, you're actually going to be adding them. So it's going to be x n plus 3. So we're going to go ahead and go back into here. So it's going to be negative 1 x n plus 4 over n plus 1. And now we've done most of the problem already. We've basically taken this entire function inside of the integral, and we've converted it to a series. But now we have this integral to worry about. As you can see down here, we have this integral right here that we have to worry about. So now we're actually going to be taking the integral and integrating all of this interior a second time. So this is a double integral, which is actually really cool. We're going to be negative 1 to the n plus 4. Since we're integrating, we're going to be power ruling it. So we're going to be putting it up 1 and then divide. So it's going to be to the 5th, which is over n plus 1 n plus 5. So this is actually the finalized series, except we have to add a plus c because you're integrating. When there's an integration, you always have a constant that comes after. Yeah, so this is the finalized series. As you can see, we do a lot of stuff. We do double integrals, and that is one problem, ladies and gentlemen. So I hope you found this interesting. If you have any questions, I probably won't answer them in the comments because I don't even know how this works, really. Wish me luck on the test in 3 days. If you really enjoyed this, highly recommend taking calculus in your high school class. Anyway, thank you so much for watching. We'll talk to you later, and peace.